Thank you so much for attending this talk about architecture for flow with Wardley Mapping, domain-driven design, and Team Topologies, and great to be back again. So, most initiatives that try to optimize or change a system are usually directed at improving parts taken separately. So they tend to focus on local optimization of the separate parts of the system. But from a system thinking lens, local optimization of separate parts of a system will not improve the performance of the whole. Dr. Russell Eckhoff, one of the pioneers of the system thinking movement, stated that a system is more than the sum of its parts. It's a product of their interactions. The way parts fit together, that determines the performance of a system, not on how they perform taken separately. And he also claimed that if the systemic nature of a system or organization is ignored, their effort of improving and changing that system are doomed to failure. So when building systems in general, we are facing the challenges of building the right thing and building the thing right. Building the right thing addresses effectiveness and addresses questions: how aligned is our solution to our business and user needs? Are we generating value for our customers? Have we understood the problem, and do we share a common understanding? Building the thing right, on the other hand, focuses on efficiency, for example, efficiency of our engineering practices. And it's not only crucial to generate value, but also being able to deliver that value to our customers. And how fast can we deliver changes, and how fast and easy can we make a change effective and adapt to new circumstances? And, so the one does not go without the other, but as Dr. Russell Eckhoff pointed out, doing the wrong thing right is not nearly as good as doing the right thing wrong. So by considering the whole and having effectiveness and efficiency in mind to build the right thing right, we need to have a holistic perspective to build adaptive systems. And one approach that I would like to share with you today is combining the perspectives of business strategy with Wardley Mapping, software architecture and design with domain-driven design, and team organization with Team Topologies in order to design, build, and evolve adaptive socio-technical systems that are optimized for a fast flow of change. And I would like to start with an example. I would like to put these three perspectives together by evolving a legacy system. And we're using a fictitious example of an online school for junior students based on a legacy system built, run, and supported by functional silo teams. And we are going to start this evolution of the legacy system by starting with a team and analyzing their current situation in regards to delivery bottlenecks and team cognitive load. Due to handover, the functional silo teams reported about a high communication and coordination effort between teams when implementing and releasing changes. Dealing with a big ball of mud with a messy model and fuzzy boundary leads to high team cognitive load and also tight change coupling. And it takes a high amount of effort to understand a piece of code. And also the team reported that there exists no clear ownership boundaries. So the teams were facing delivery bottlenecks impeding the software delivery performance. Due to on-premise infrastructure, the operational efforts consist of configuration, backup and recovery mechanisms, maintenance, including upgrades and security updates, monitoring, scaling, and so on. So the infrastructure teams were facing very high level of operational efforts. But as a reminder from system thinking, if we plan to locally optimize only separate parts of the system, that will not improve the performance of the whole. To improve the performance of the whole, we need to tackle the situation from a broader perspective and also understand the environment an organization is operating and competing in. And this brings us to a Wardley map, which is representing the landscape of an organization. And a Wardley map is part of Wardley Mapping. Who of you have heard of Wardley Mapping before? Oh, a couple of hands. Who of you have created a Wardley map in an organization? Yeah, a little less hands, but also a fair amount of people. So Wardley Mapping itself is a business strategic framework invented by Simon Wardley. and it helps to design and evolve effective business strategies based on situational awareness and movement. And it's following a strategy cycle. And the strategy cycle is a representation of change and how we need to react to that change according to Simon Wardley. And it starts with a purpose, the why of our business. In our case of the online school, it's about providing high-quality education for junior students everywhere and help teachers engage with their students online. The next section is the landscape an organization is operating and competing in, visualized with a Wardley map. So let's create a Wardley map of this online school example, reflecting or visualizing the current state. A Wardley map is composed of a y-axis and an x-axis, and the y-axis is representing the value chain. To derive from the value chain, it starts with identifying your users first, and your users could be your customers, your shareholders, your business partners, internal users, and so on. In our case, we are focusing on the teachers and the junior students as the users of our online school. The next step is identifying the user needs. And the user needs are the problems that the users would like to get solved. And they are the subject area for which we build a product. So the teachers would like to create course content, planning a class, helping the students during the learning progress, evaluating these students' learning progress. The students would like to study courses, requesting and receiving help, and also receiving evaluation feedback from the teachers. And both need to sign up and sign in as well. And both the users and the user need, they represent the anchor of the map that all subsequent components relate to. The next step is identifying these components that fulfill the user needs either directly or indirectly by facilitating other components in that value chain and determine the dependencies and positions of this component in the value chain. So at the top, we have those components which are most visible to the users, where your users are touching your system. And in the bottom, it gets more and more invisible to the users. And the value to the user and the visibility, they are closely correlated. So the more visible a component is, the more value it generates to the users. So in our case, the teachers and the students are interacting directly with an online school component, which is located at the top of our value chain. And at this current state, we are dealing with a big ball of mud as one single component that we are going to decompose later when we come to domain-driven design. And this online school component depends on other components, on infrastructure components, such as data storage, search engine, message broker, SMTP server, compute platform, which is depending then on virtual machine component. And we are going to use these components and plot these components from left to right on the x-axis on the evolution stages. So at the left, we have Genesis with brand new things, then product and then custom build, then product and rental such as off-the-shelf products or open source software solutions, and then commodity and utility on the right. And let's look at some climatic patterns that are affecting our landscape to determine the stage of evolution. So that brings us to the next section of our strategy cycle, the climate or the climatic patterns. Climatic patterns, they describe external forces and rules that are impacting our landscape, over which we have no control. But understanding these climatic patterns is important to anticipate change, according to Simon Wardley. Understanding the climatic patterns gives us an idea where the landscape might change and where to invest in the future. And Simon Wardley has collected or compiled a collection of roughly 30 different climatic patterns. We are not going through all of them today, just only 2 of them. And one of the climatic patterns is that everything evolves from left to right through the forces of demand and supply competitions. For example, if you look at cloud-hosted services, is one example of this climatic pattern. What was decades ago non-existent evolved through Genesis, custom build, became product and rental, and now commodity and utility. Another climatic pattern is that while the components evolve through the evolution stages, their characteristics changes. So we are their characteristic changes from the uncharted, the undefined, constantly changing, chaotic, poorly understood domain. And while it evolves through the evolution stages, it becomes more and more stable, mature, where we are then dealing with a commonly understood, ordered, stable domain on the right. And we can use these characteristics to determine the stage of evolution per component of our value chain. For example, our online school component is going to be, or is a volatile at the current state, a volatile component which is changing frequently, providing competitive advantage. So that should go into custom build. And this online school component and the infrastructure components, such as search engine, message broker, and so on, they are more stable, mature, widespread, and they can go into product and rental or commodity and utility evolution stage. And we can use different methods per evolution stage. And there we come to the next section of the strategy cycle that is called the doctrine. And Simon Wardley has compiled a list of roughly 40 different doctrinal principles. We are not going through all of them, just a few. And doctrinal principles are enabling an organization to deal with changes, to be able to respond to changes quickly, to be able to absorb changes gracefully. And one of the doctrinal principles is to use appropriate methods per evolution stage. And this means that we should build components in Genesis and custom build in-house, preferably using agile methods. Or that we should use or buy off-the-shelf products or using open source software solutions for components in product and rental, with preferably lean methods. Or that we outsource components in commodity to utility suppliers or using Six Sigma methods. And when we come back to our online school component, we are then going to, or we are at the moment building our online school component in-house with, for example, agile methods. And we are using open source software solutions at the current state for the infrastructure components, and the virtual machine component is provided as an off-the-shelf product from a service hoster provider at the current stage, because we are then going to evolve it. And we are going to use this Wardley map as a foundation for future discussions while we are evolving our legacy system. And besides using appropriate methods per evolution stage, there are other doctrinal principles, like for a business it's important to know who your users are. We need to focus on the user needs to build the right thing. We need to know the details in terms of what is necessary to fulfill the user needs. And we need to use a common language to communicate effectively, and also challenge assumptions by sharing this map and creating a better map, or also creating a better understanding of your landscape, and also create a better understanding of your domain. And also further doctrinal principles is like breaking your landscape into smaller contracts, and also using small teams, provide mastery, purpose, and autonomy, optimize for flow, and also design for constant evolution. So these are just an extract of doctrinal principles, but the Wardley mapping itself is more identifying or highlighting what principles to apply to optimize for fast flow of change, while domain-driven design and team topologies are going to help us to implement these doctrinal principles. So let's go back to the team's perspective. To optimize for fast flow of change, from a team perspective, we need to avoid functional silo teams with handover. Instead, we need to aim for cross-functional autonomous teams that are responsible for designing, developing, deploying, operating the system they are responsible for. We should avoid handover, because we don't want to hand over work to another team. We should aim for small, long-lived teams as the norm. And the teams shall own the system or subsystems they are responsible for, so they need to have end-to-end responsibility to achieve fast flow. We need to minimize the team's cognitive load, because on the other hand, if we are largely exceeding the team cognitive load, that will lead to delivery bottlenecks and also creating then delays and software quality issues in general. And while the communication within a team is highly desired, we need to restrict a high ongoing communication coordination effort between the teams to enable fast flow. And that's where Team Topologies can help us with their well-defined team types and their well-defined interaction modes. So who have heard of Team Topologies before? Awesome, some hands are coming up. So Team Topologies provides different team types, such as the cross-functional autonomous stream-aligned teams that are aligned to a continuous stream of work, focusing on a fast flow of changes. But to be able to focus on a fast flow of changes and to be able to produce a steady flow of feature deliveries, it needs the support from the other teams. For example, from the platform teams that are responsible for platforms which are usually abstracting away infrastructure, networking, cross-cutting capabilities, and that provide self-services, APIs, and tools to using that platform they are responsible for, which can then be easily consumed by the stream-aligned teams. All the stream-aligned teams can receive active help from the enabling teams that are supporting the stream-aligned teams to acquire missing capabilities. Or they can also receive support from the complicated subsystem teams as an optional team type. These teams can support the stream-aligned teams on particularly complicated subsystems that require very specialized knowledge. So in all of these team types, they have the focus, or their aim is to increase the autonomy and also reduce the team cognitive load of the stream-aligned teams in order to enable a fast flow of change. But arranging these teams and these team types is not enough to become effective. How these teams are interacting with each other and when to evolve the interaction mode is also very crucial for organizational effectiveness. And Team Topologies promotes 3 different interaction modes. So there is collaboration. With collaboration, the teams are working very closely together, aiming for a common goal, and it's suitable for rapid discovery and innovation, for example, when exploring new technology stacks together. Another interaction mode is X as a service. So X as a service is useful when one team would need a code library, a component, an API, a platform that can be effectively provided by another team as a service, and it suits well where predictable delivery is needed. The third interaction mode is facilitation, and this is the interaction mode that comes into play when one team would benefit from active help of another team. And this interaction mode is a typical interaction mode for stream-aligned teams. And the combination of these team types, these 4 team types and these 3 interaction modes, they promote organizational effectiveness and also help to apply part of Wardley doctrinal principles. So while we are applying the Team Topologies, we are also automatically applying some of the doctrinal principles of Wardley Mapping. So let's architecture for flow, and let's go back to our Wardley map that we have previously created, visualizing the current state of our online school example. And to architecture for flow and to optimize the system for a fast flow of change, it's important to know where the most important changes occur in our system, the streams of changes. And the type of streams can vary in every organization. So there could be a role, task, activity, geography, customer segment-related activities, stream types. So coming back to our Wardley map, to our online school example, we are focusing on the activity-oriented stream types and using the user needs of our Wardley map as good candidates for activity streams. For example, creating course content, planning a class, are reflecting good candidates for activity streams. So they need to be focused on when optimizing for fast flow of change. A next step is that we need to understand our problem domain, and so the users and the user needs not only represent the anchor of our map, but also constitute the problem domain in context of the domain-driven design. And so understanding the problem domain and partitioning it into smaller parts, the subdomains, brings us then to the next perspective of domain-driven design. And domain-driven design comes with a core statement: in order to build better software, its software design has to be aligned to its business domain, its business needs, and its business strategies. And while we are applying domain-driven design, we are also applying automatically some of the doctrinal principles of Wardley Mapping as well. So when we partition or distilling our problem domain and distill it into subdomains, not all subdomains have the same value to the business than others. And so there are different types of subdomains, such as core, supporting, and generic subdomains. So while we are distilling it in the problem space of strategic design, the core domain, that is the one that is the essential part of our system, providing competitive advantage. So it should be hard for competitors to imitate or copy. It just should be quite complex and tends to change frequently. So that is the part of our system that we need to build in-house and can go either into Genesis or custom-built evolution stage. The supporting subdomain supports the core domain. It provides no competitive advantage. It's usually quite simple, and it does not change that often compared to the core domain. And we should look out for using or buying off-the-shelf products or using open source software solutions for the supporting subdomain. And if this is not possible, and if we need, then it goes into product and rental. And if it is not possible, if we need to custom build the supporting subdomain, then we should be aware that we should not put too much development effort in this part of the system because it does not provide competitive advantage. The generic subdomains, these are subdomains that many business systems have, for example, authentication, payment services, and so on. So they are not core. They provide no competitive advantage, but without them, the businesses cannot work efficiently. So they are generally complex, but already solved by someone else, and they tend to be quite stable and mature. So we should focus on buying or using off-the-shelf products or using open source software solutions or outsourcing to utility suppliers that are then applicable for the generic subdomain. So let's go back to our online school. Let's go back to our online school example. Where we have then identified different core domains that are providing competitive advantage, such as creating course content, planning classes, helping students, and also studying courses from the student perspective. So they provide competitive advantage, leading it to a high level of differentiation. They embody a high level of complexity and tend to change frequently. They are not widespread in any other business system because that's our differentiator. And that's the part of the system that we have to strategically invest in most because that's the one that gives us competitive edge. The evaluation of students' learning progress, on the other hand, does not necessarily provide competitive advantage. So it's less complex than the core domains. It's changing less frequently, and we should not invest too much into this business system, into this part of the system. The generics subdomains of signing in and signing up, this is so authentication and registration. These are subdomains that many business systems have, so they are widespread, standard, expected, and with a high level of ubiquity and a high level of stability. And so they are generally complex, but already solved by someone else. And so we should not invest too much into this part of the system because it does not provide competitive advantage. So far, we have dealt with the problem space of strategic design, distilling our problem domain into subdomains and also discovering the core. The next step could be to go to the solution space of strategic design, where we decompose our system into modular components, the bounded contexts. The bounded contexts, they define where a single domain model can be applied, where a single domain model lives in, and they provide a unit of mastery, purpose, and autonomy. And they also they help to split our system apart into smaller components, but also serve well as different boundary types. For example, serving very well as ownership boundaries, which I will address in a second. And to design bounded context and domain models, it involves a close collaboration between the domain experts and the development teams, and in order to gain a shared understanding of the domain and a better understanding of the domain. And there are different techniques available, such as event storming, domain storytelling, user story mapping, example mapping, and so on, that you will hear and attend hands-on in this conference as well. So in our example, we have applied these techniques. We have closely collaborated with the domain experts as development teams. And we have designed the bounded context of content creation, course studies, class management, and learning support. They fulfill the core domain-related bounded context. So that's the one that we are going to build in-house. And then, on the other hand, the bounded context of student evaluation and notification handling, they are belonging to a supporting subdomain. And there might exist several solutions on the market already. However, the team decided to custom build it because they require a higher level of specialization. So they decided to custom build it, but with the awareness not to put so much development effort in that part of the system. And the bounded context of identity and access, this fulfills a generic subdomain-related bounded context, and that is something that we are going to use either off-the-shelf products or outsourced to utility suppliers. So the next step is then to find suitable team boundaries. And as I mentioned earlier, bounded contexts, they serve very well as team ownership boundaries for stream-aligned teams, forming a unit of purpose, mastery, and autonomy. And also, the next step in architecting for flow is to optimize the team cognitive load. As I mentioned earlier, if it's largely exceeded, then it will will result into delivery bottlenecks. And for optimizing for fast flow of change, it requires to limit the number and the type and the complexities of the system or components that a single team is taking ownership of. So this brings us back to the evolution stages of our Wardley map, reflecting the different characteristics per evolution stage. So at the left spectrum of our Wardley map, at Genesis and custom build, there we are dealing with a high level of uncertainty. So as you remember, so their components are changing constantly, very frequently. And the rate of change is very high, and in comparison to the components of the right spectrum of our Wardley map. At the right spectrum of our Wardley map, we can draw on best practices leading to a clear path to action. And so for every evolution stage, we can apply different methods regards to the path to action, going from best, good, emerging, and novel practices. And the more unclear the path to action is, there's a tendency that the higher the cognitive load might be. So that means for a single team that it could take care of ownership of more or larger components residing on the right spectrum of a Wardley map than residing on the left spectrum of the Wardley map. Another aspect to optimize for team cognitive load is to establish clear ownership boundaries. And to establish clear ownership boundaries, the bounded context should be aligned to a single team only. We shall not share bounded context across teams, because that would diffuse the ownership of teams. However, one single team can own several bounded contexts. Another step in architecture for flow is identifying the services that are providing that are needed to support a reliable flow of changes. So, for example, the services that we are then addressing for the components that we are addressing then more in the product and rental or commodity and utility evolution stage, where then the streamline teams, they rely on platform teams providing platform as a services that the streamline teams can then easily consume. And they should aim for a single viable platform, the platform teams, that is a platform that is just big enough to fulfill the customer user needs, but not become bigger than needed. And it could start with documentation, with standards, with best practices, with templates, and can evolve later into self-service APIs and tools for consuming the platform. And also, we need to mind dependencies and high communication bandwidth and coordination efforts between teams. They need to be eliminated. And we also need to identify capability gaps to help teams acquire missing capabilities that is then the responsibility of the future enabling teams. So, having all these considerations in mind for architecture and for flow, a possible team constellation could look like this. So in general, in organization, we are dealing with, or we are having, the majority of teams would be then the streamlined teams. So in our case of the online school, the core domain-related bounded contexts are going, the 4 core domain-related bounded contexts are going to be split among 3 streamlined teams. The supporting and generic bounded contexts are going to be taken care of another streamlined teams, and the infrastructure components are going to be handled by 1 or multiple platform teams. But before we go into the implementation phase and the transition phase, we also need to mind one thing as well, and that is potential efficiency gaps, because we don't want to build or evolve our system based on inefficiencies, because also inefficiencies impede our fast flow of changes. So for example, if we are using components in our organization in-house that are more evolved, that there exist more components in the market that are more evolved, that might indicate an efficiency gap. For example, if we are using custom-built components in our organization, but these components are available as utility, then we are lagging behind and encounter inefficiencies. And the larger the gap, the less efficient an organization might be. So we need to close this efficiency gap. For example, in our example, to move on-premise infrastructure components to cloud-hosted services, which I will address in a second. So now the question is how to go from A to B, so how to transition. So far, we have not touched any code yet. We have not reorganized any team yet. And we are going to implement flow optimization by a team-first approach with the help of dynamic reteaming and an evolution of Team Topologies interaction modes, and that are then executing and supporting a cloud migration strategy. So we are starting with the infrastructure components first to close the efficiency gap. And to close the efficiency gap, since we are dealing with the infrastructure, we are forming a platform team first from members of the previous back-end and infrastructure teams. And this platform team is going then to kick off the cloud migration strategy. And it's going to be, working on the site with the freedom to discover, explore, learn, and assess cloud migration strategies. It's going to determine a migration plan, a migration path, and also a migration, determine the new platform. And so the platform team decided to start with the replatforming cloud migration strategy. And with replatforming, we are modifying the underlying infrastructure while moving components from in-premises infrastructure to the cloud-hosted services, while we keep the applications architecture the same. So this can be done through an incremental process from moving component to component to the cloud environment, so that at the end we have moved our on-premise infrastructure component to the cloud environment. And this also helps us then to eliminate the efficiency gaps. As soon as the infrastructure components has been migrated to the cloud, the remaining infrastructure team can then merge into the platform team and can split later into smaller teams if this is applicable. And the next step is now we have replatformed our infrastructure to the cloud, but we also still want to modernize our big ball of mud with messy model and fuzzy boundaries and eliminate their delivery bottlenecks. So that is then where the next cloud strategy comes in through refactoring our monolithic big ball of mud, and where we want to incrementally decompose our big ball of mud into this previously designed bounded context that we have designed before. And we start this refactoring journey with forming the next team. The next team type is starting the first streamline teams from members of the previous front-end and back-end team, kicking off the refactoring journey. In the meantime, the remaining front-end and back-end teams, they can then merge together as one joint team to take care, as one joint team in a preliminary state, and to take care of the remaining monoliths as long as it is existing, and as one team with no handover involved. And later on, they can split in their streamline teams as well. So let's come back to the first formed streamline teams. So it starts the refactoring journey by an evolution of Team Topologies interaction modes. So at the beginning, the streamline teams is closely collaborating with the previously formed platform team to jointly discover and assess possible cloud options that are applicable for the bounded context that the new streamline team is going to be responsible for. And the new streamline team might decide to refactor their bounded context using serverless technologies. As soon as the cloud option has been discovered, then the close collaboration can evolve into a limited collaboration and a limited facilitation where the interaction moves from daily to on-demand collaboration and facilitation. And later on, as soon as the serverless ecosystem has been more established in the organization, the platform team can provide platform as a services consisting of best practices, standards, APIs, tools that are then there to be easily consumed, to easily consume the platform they are responsible for by the other teams. So that was the first bounded context that we have refactored. The next step is then to form the other streamline teams by splitting then the previously merged team. And they go now on their refactoring journey, also supported by an evolution of team topologies. For example, the second streamline team that has been formed can then get active help from the previous platform team and the previous streamline team. For example, the platform team can also discover possible cloud options for their bounded contexts, and they can also coach them about CI/CD pipeline in the serverless ecosystem, and they can also point to the platform as a service that they have established before and incorporate their feedback while they're using it. And the first form streamline team can also coach the new streamline teams, for example, about how to implement serverless function in a hexagonal architecture. And then the next streamline teams can go on their journey, splitting from the previously merged team types, its previously merged team, and go on their refactoring journey, again getting support from the previous platform team and the previous Streamline teams, helping them with their cloud options and coaching them how to use this new environment to refactor their bounded context, so that at the end we have refactored our monolithic big ball of mud and decomposed it into modular bounded context based on serverless technologies with the aid of evolution of Team Topologies interaction modes and dynamic reteaming. So that we have optimized our system, our legacy system, for fast flow of change. So that enables us at the end that we could eliminate our functional silo teams with handover and evolving them into the well-defined team types and the well-defined interaction modes of team topologies. We could restrict the high communication and coordination effort between the teams. We could decompose our monolithic big ball of mud with a messy model and fuzzy boundary into a system with clear domain models and clear bounded context, which then also provides very clear team ownership boundaries. We could move from a tightly coupled system into a loosely coupled system, and we have had the opportunity to optimize our high team cognitive load and to reduce it, due to limit this number and size and type of complexities one single team is responsible for, but also establish clear ownership boundaries. So that at the end we could reduce the delivery bottlenecks impeding our software delivery performance and increasing our software delivery performance in itself. And also we could manage to, while moving components from infrastructure, from on-premise infrastructure to the cloud, offloading the management of infrastructure to the cloud house, to cloud providers, and optimize our efficiency gap. So the combination of Wardley Mapping, domain-driven design, and team topologies that helps us to understand the environment an organization is operating and competing in. It helps us to gain domain knowledge and discover the core, providing competitive advantage. It helps us to know, to identify what components to build in-house, where to buy or use off-the-shelf products or using open-source software solutions, and where to outsource to utility suppliers. It helps us to decompose our problem domain into modular components, the bounded contexts. It helps us to align our teams and evolve their interactions to the system we build and the strategy we are planning. It helps us to identify potential efficiency gaps and also eliminate bottlenecks and increasing our software delivery performance. So that at the end we are able to deal with changes, that we are able to respond to changes quickly, and that we can absorb changes gracefully. So the combination of Wardley Mapping, domain-driven design, team topologies, helps us or provides a holistic, powerful tool set to design, build, and evolve adaptive socio-technical systems that are optimized for a fast flow of change with a focus on improving the performance of the system as a whole. And with that, I'm at the end of my talk. So I have added some references that you, just a small extract. And in case you are a little bit more interested in connecting the more dots, there's going to be published a book soonish. I'm not saying the time. So thanks a lot for listening, and I'm looking forward to your questions. I'm available until the end of the conference, so please ask questions to me at the lobby, for example. Thank you so much for listening.
Thank you so much, Susanne.
Thank you.